Assalamualaikum and salam sejahtera. My name is Muhammad Fahmudin, and today our group will present about the Engineering Mathematics 3 project, which is the title Moment of Lamina. This is my group member Uzafa Wafin Zaminan, Afri Majid Osman Adan, and Muhammad Najhan bin Muhammad Yusof. And then we carry on to the introduction. First of all, we have to know that a planar lamina is a figure of a closed set E of finite area in a plane with some mass, which is M. And then because of the mass of a lamina is proportional to its area, this is useful for determining moments of inertia and center of mass with a constant density. Okay, for the moment of lamina formula, which is the my, is the moment of the entire lamina about the y-axis, and mx is the moment of the entire lamina about x-axis, with summation and integration taken over a planar domain. You can see the formula below, which is my integral the x dA, and about the x-axis, which is an x, y, buff x, y. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najhan bin Yusuf. So I will talk about the data calculation. Generally, as we all know, center of mass of rigid physical object can be determined by an experiment. For example, is table H method. So basically, this method can be applied to any object with any shape, but at least they have one flat side in order to identify the center of mass. So the experiment is done by putting an object on the table, hence we pushing it slowly approaches to the edge of the table. Then when the object is about to fall, we draw a parallel line that is parallel to the edge of the table. So next we need to rotate the object about 90 degree in angle, and the same procedure is repeated, which is we draw the line parallel to the table when the object is about to fall. Finally, the intersection of the two lines will indicate the center of mass of the object. So we can see here the figure 4 shows the table H method to determine the center of mass. So for further understanding about finding the center of mass of any object or a system, here is the example that I attach, the example of calculation to find the center of mass. The calculation is done manually and by using the software, which is Maple software. So the question here is, find the center of mass of a lamina with edges given by the lines x equal to 0, y equal to x, and y equal to 5 minus x, where the density is given as rho xy equals to 3x plus 4y plus 3. So next we have to identify the curve line based on the given function. As in this case, the line is drawn by using Maple software, but the combined curve cannot be drawn manually. It cannot be drawn by using the Maple software due to some problem. So I draw it manually on a graph paper. First thing first, we have to find the mass, which is m. So we have to express as an iterated integral. For your information, the first method I use is by using the Maple software. So we express as an iterated integral. So next, after we have expressed as an iterated integral, we have to settle the inner integral. So we have here integrate with lower limit x and upper limit 5 minus x bracket 3x plus 4y plus 3 dy. So we settle the integral here and we get negative 6x squared minus 11x plus 65. So we plugging into the outer integral to get the value of m. So integral with lower limit 0 to the upper limit 3, and we put the value that we get from the inner integral. So we have the value of m here is 183 over 2. So the next step, we have to find the my, which is double integral lower limit 0, upper limit 3, and lower limit x to the upper limit 5 minus x. So when we want to find the my, we have to put x. So this is 3x plus 4y plus 3 dy dx. So we settle the inner integral. which is integral with lower limit x to the upper limit 5 minus x. So we integrate the function, so we get negative 6x cubed minus 11x squared plus 65x. Hence, we plug into our outer integral to get the value of my, which is 72. Then we have to find the mx. So the mx, we have to put y in front of the function. So after we settle the inner integral, we get 1225 divided by 6 minus 8 divided by 3 x 3 cubed plus 5x square minus 155 divided by 2x. So we plug into the outer integral here and we get the value 1019 over 4. After we find the my and mx, we have to calculate the center of mass, which is the formula is my over m and mx over m. So we just plug the value that we get into the formula and we get 48 over 61 for the my over m, and for the mx over m is 1019 divided by 366. So next, we have to determine the center of mass manually. The procedure is quite the same. First, we have to find the mass, which is m, with double integral, with outer integral lower limit is 0 and upper limit is 3, and the inner integral with lower limit x to the upper limit 5 minus x, and we put in the function that given. So we have to settle the inner integral first with lower limit x and the upper limit 5 minus x. So after we settle the inner integral, we get the value negative 6x squared minus 11x plus 65. So we plug into our outer integral, then we settle our outer integral, and we get m is equal to 183 minus divided by 2. Next, the procedure is the same. We have to find the my, and we have to put x in front of the function. So double integral with same lower limit and upper limit. We settle the inner integral, which is lower limit x up to upper limit 5 minus x. So we integrate, we get 3x squared y plus 2xy squared plus 3xy. Then we put our lower limit and upper limit value into the function and we minus it, and we get negative 6x cubed minus 11x squared plus 65x, and we put our value that we get into the outer integral, and we have my equal to 72. Next, we find the mx. Double integral with same limit, but we have to put y in front of the function, dy dx. So the inner integral which is with lower limit x and upper limit 5 minus x. So we integrate the function, we get 3xy squared over 2 plus 4y cubed divided by 3 plus 3y squared divided by 2, and we plug in the value of lower limit and upper limit into the function, and we get 1225 divided by 6 minus 8 divided by 3x cubed plus 5x squared minus 155 divided by 2x. So the value that we get, we have to put into our outer integral, which is with lower limit 0 and upper limit 3, and then we get the answer for mx, which is 1019 divided by 4. And finally, the last step, we have to find the center of mass with formula my over m and mx over m. So we just put the value of my and mx with m into the formula, and we get the center of mass for the question is 48 divided by 61 and 1019 over 366. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Zafrullah bin Zaminan. My metric number is TF190055. So today we'll talk about filler table. So as we know, filler table is divided into 4 parts. First part is facts, second part is ideas, third part is learning issues, and the fourth part is the action plan. This filler table is regarding to our task. For the first fact is we got from the question x equal to 0, y equal to 5 minus x, and y equal to x were given from the question. The second fact is the density is given as rho xy equal to 3x plus 4y plus 3. The third is the line is drawn by the using mapper software. And the fourth is the combined line function is drawn manually. The ideas is we put the x equal to 0, y equal to x, and y equal to 5 minus x into mapper software to get the line. Then the second ideas, we got 5 ideas here for the density given. The first one is express an iterated integral. Second one is calculated the inner integral. The third one is plugging into the outer integral to get m value. The fourth one, find the my and the mx value. The fifth, find the my per m and mx per m. The fourth ideas is download the software from the internet. The last one, we use the graph paper to plot the graph and line. The learning issues we got from our task is we have 5 issues. First one is find the line based on the given function. Second one, apply the double integral equation m equal to integral 30 integral 5 minus x and x 3x plus 4y plus 3 dy dx. The third one, we determine the mass m. The fourth, determine the my and ms. The last one, finally find the my per m, mx per m to get the center of mass. Action plan, we have 3 action plans. The first one, learning how to use the mapper software through the YouTube. The second one, revise the integral topic from given chapter 2 lecturer's note. The last one, check the calculation together with groupmate to avoid mistake. This is our filler table. That's all from me. Thank you so much.
Assalamu alaikum. My name is Edmund Litzman and I'm the number is BF1800. I'm group 8. Our main topic is moment of LAMINA. My part of the project is a conclusion. LAMINA is a small section with an infinitesimally thin section in 2-dimensional as well as 3-dimensional body. The moment of LAMINA implies an evaluation of moment of mass as well as the moment of inertia of body by integrating integration. The lamina of the dimension of the body are regular or irregular. In general, the moment of inertia varies as much as the same form in a rotational motion. The mass varies in the linear motion. The moment of inertia of y is what makes it difficult to start or stop the rotation of the y, just as mass of the car is what makes it difficult to start and stop the motion of the car. That's all for my part and also for the group. Thank you very much.